The name of this lesson is Parallelograms. We started this unit talking about the measure of interior and exterior angles of polygons, and now we're going to go in and talk about some properties of some specific polygons. So the first term we're going to introduce is quadrilateral. Y'all probably know this term, but that is a very general term. It refers to a closed figure formed by four segments intersecting at their endpoints. So we know a lot of special ones, and that's what we're going to talk about. But in general, it just means a four-sided polygon. Pretend that's not a curve there. But it's a very general term, whereas a parallelogram now is a special quadrilateral. It's a quadrilateral in which opposite sides are parallel. Okay, so I'll try and draw one. Something like this, where this side is parallel to this side, and this side is parallel to that side. And when that happens, there's some special properties that we're going to talk about. And then the last term here is a diagonal. So a diagonal is a segment joining opposite vertices in a polygon. So in this one here, there's a diagonal, there's a diagonal. We also have diagonals in this one as well, but pretend those are straight lines. I did my best. Okay, so now let's look at some specifics. The first thing that they want us to do is to identify or name some parts of this parallelogram. It's important that we understand what parts we're referring to and that we name them properly. So the four vertices, those are just the points in the corners there, okay? So we have M, N, P, and Q. Notice that I put commas between them. Okay, when we're talking about vertices or points, we name them with capital letters and they're individual. So put commas between them. And the order that you put them in doesn't matter. You could put them in any order you want. Because now when I name the parallelogram, I'm going to name the parallelogram by its vertices. And it doesn't matter which vertice you start with. I'm going to start with M, and I typically go in clockwise order. You cannot skip. This is parallelogram M, N, P, Q. Notice it looks just like naming the vertices, however there are no commas. That's how I know I'm not talking about the points, but I'm talking about the parallelogram because I have no commas. Now, could you name it different? There's a lot of different things you could name this. Okay, you don't have to go clockwise. Typically, I go clockwise, and that's how I see it done most. But you could go counterclockwise, and you could start anywhere. I could start with P and name it going in this order. So it would be P, N, M, Q. Okay, so the order matters only in that you can't skip any, and it doesn't matter if you go right or left. No commas. All right, so now the opposite sides. Let me clear this. Okay, so I'll go back and put M, N, P, Q, and M, N, P, Q. Now the opposite sides. So the opposite sides are the sides across from each other, and sides are segments. So you're going to put MQ, and you're going to put a line over it to show that it's a segment. And the opposite side would be MQ, and then the one across from it is NP. You can put NP or PN. The order there doesn't matter. We're just naming that segment. We also have another opposite side. We have MN and PQ. Okay? Opposite angles. Opposite angles are the angles across from each other. So this angle here, M, is opposite of P. So angle M and angle P. It's important that you put the angle symbol in front of it so we know you're talking about an angle. We also have angle N and angle Q. So those are opposite angles. Now we have consecutive angles. Consecutive angles are the angles that are next to each other. So we have more than two of them because I can look at M and N and those are next to each other. So angle M and angle N are consecutive, but so is N and P. Those are next to each other. Angle N and angle P, as well as angle P and angle Q. And lastly, we have angle Q and angle M. So we have 4 pairs of consecutive angles. And then naming the diagonal is just, these are segments, so it would be MP and NQ. So even though they weren't drawn in, we could name them or draw them ourselves. Okay, so that is important that you know when we're talking about opposite sides and opposite angles, which ones, and consecutive angles and the diagonals, and to name them with the proper labels. Okay. Next, we are going to look at properties. These are going to be real important, and you're going to refer to them a lot. So I'm going to pause the video for a moment so that I can type these in so it will be easier for you to read. Okay, I have typed in the words here, and so please make sure that you get these down properly. These are going to be real important. Then you also, not only by putting the words there, you need to go over and mark your picture. So let me show you how to do that. Opposite sides are parallel. So that means that, this side is parallel to this side. So you put these little arrows, and this side is parallel to that side. So opposite sides are parallel. Parallel sides have equal slopes. So later we might need that. But opposite sides are congruent. So that means that this side is congruent to this side, and this side is congruent to this side. Opposite angles are congruent. So this entire angle right here is congruent to this angle here, and this angle here is congruent to this one. Consecutive angles are supplementary. That means they add up to 180 degrees. So let me see. So this angle here plus this angle here is 180 degrees, as well as this angle here and this angle here are 180 degrees. And we'll look at that in some examples in a moment. And diagonals bisect each other. Okay, bisect each other. That means this is a midpoint. That means that this segment right here is congruent to this one. And this segment right here is congruent to that one. So these are the properties. Make sure that you have them all written down, and we're going to use those properties to solve some problems. Okay, you can pause if you need to. All right. Draw and label each parallelogram described, and then determine the value of x. Okay, so you don't have to be anything fancy, but here's my parallelogram. Sometimes they look more like rectangles. That's fine. I just need the visual because I have A, B, C, D. So you need to label. Doesn't matter where you start, but go in order. Because if you don't, you won't do the problem correctly. So there is A, B, C, D. So A, the measure of angle A is x, and the measure of angle D is 2x minus 3. So I look at my picture and I see those are consecutive angles. And consecutive angles in a parallelogram are supplementary. That means they add up to 180 degrees. So I'm going to add 2x minus 3 and x. So that's going to be 3x minus 3 equals 180. Now we just solve. Add 3 to both sides, and we get 3x is equal to 183. And 183 divided by 3. Sorry, get my calculator back on. Is 61. So x is equal to 61 degrees. So please try and do the quick check yourself. Please pause. Okay, hopefully you paused and you see that again we have consecutive angles. So we're going to add 3x plus 4 and x, and that gives me 4x plus 4 equals 180. If I subtract 4 from both sides, I get 4x equals 176, and 176 divided by 4 is x is equal to 44 degrees. Okay. Example 3. Okay, we have some angles and we have some measurements of sides. Well, opposite sides are congruent, so those are congruent, and opposite angles are congruent. So this is congruent to this. So x, we put 3x plus 4 equals 16. Subtract 4 and you get 3x is equal to 12, or x is equal to 4. And then for the angle, y minus 60 is equal to 56. So add 60 to both sides and you get y is equal to 116 degrees. Please pause the video and do the quick check. Okay, here we have opposite sides, so 8g minus 3 equals 25. Add 3 to both sides, and you get 8g is equal to 28. So divide both sides by 8. And you get g is equal to 3.5. Now f, a little different. These are consecutive angles. So those angles are consecutive. I should put 2 marks on one because they're not congruent, they're consecutive. Consecutive angles are supplementary, which means they add up to 180 degrees. So f plus 30 plus 72 equals 180. So f plus 102 equals 180, or f is equal to, subtract 102 from both sides, and I get 78 degrees. Okay. Okay, I think we have time for one more, and then we'll pause the video. X, Y, Z, W is a parallelogram. So draw a parallelogram and put the order correct. X, Y, Z, W, that's a Y, with diagonals. So they tell us about the diagonals. They intersect at point A. Okay, so the first thing you do is just draw your picture. Then they tell us that the measure of XA, so here is 3m, and ZA is 5m minus 4. You go back to your properties that diagonals bisect each other. So this is equal to that. So then it's just 5m minus 4 equals 3m. Subtract 3m from both sides, and you get 2m minus 4 is equal to 0. Add 4, and you get 2m is equal to 4. Divide by 2, and m is equal to 2. You can always go back and substitute in and make sure that that's correct. So 3 times 2 is 6. 5 times 2 minus 4 is also 6. Okay, I'm going to stop the video here. You should try and do the quick check if you can look at it real quickly, and I'll start the second video with putting that answer up. Okay, I'll start in a moment.